Please welcome Tobias, Senior Business Development and Partner Manager at Vector Informatik, and Brandy Goolsby, Director of Business Development and Sales for Embedded Software at Vector North America. With deep expertise in embedded systems and AutoSAP, they are leading voices in how software is transforming the automotive industry. Today, they'll guide us through the emerging world of the software-defined vehicle and what it means for the future of mobility.
Thank you. Thank you very much.
Buenos dias. I'm welcoming you. My name is Tobias Weber. I'm from Vector Informatik, Germany. So thanks for having us. So far, it's a very wonderful trip. We met lots of highly motivated engineers. We had great conversations already, and I'm really looking forward to have more conversations today with you. I'm here together with my colleague from North America, Brandy. And today, as it was shown in the picture and it's in the title already, we're going to talk about a new trend in the automotive industry. So the industry itself is undergoing a big change, a big transformation. And I'm not talking about electrification, but the software-defined vehicle. So today I'm going to talk about, together with Brandy, about software-defined vehicle, what we think, how the future car should be set up in order to deploy new features, new functionalities, even after production to the car. So we will have a look on different parts, different enablers, how we call it, to show you what is meant by that. Okay. First of all, we will have a look, okay, what is an SDV? What is a software-defined vehicle? You may all know, meanwhile, you can see on your cockpit, on your display, that you have the App Store, you have Apple CarPlay or Android Auto. You see the different apps. But this is not a software-defined vehicle. Software-defined vehicle means that you can, as I mentioned before, even after production, you are able to bring in new features to the car. You can customize, you can adapt, and you can improve the system, even if it's in the market already for years. And this is a big change. What is the benefit of that? There are several benefits, and I want to highlight 3 of them. One of them is you have an enhanced product lifecycle. Like I mentioned, new features can be brought to the car even after production. You can maintain the platform for many years by just deploying new or bringing new software updates to the car, like Apple is doing with our phones, for example. There's cost efficiency, obviously. You have a quick adaptation to market needs by bringing in new features without changing the hardware. We will talk about also decoupling of the hardware and the software, which is a very important thing when we talk about the SDV. And I already mentioned it, new business models. Like you have real data you get from the fleets, from the cars on the streets. You can offer new services to the customers, like predictive maintenance or traffic information. Like there are many new opportunities. And of course, customization, continuously improvement of the platforms. This is all given by that. Okay. Now, I already mentioned we have defined 5 enablers how to develop such an SDV that need, from our perspective, are crucial when you think about developing such an SDV. Let's have a look. So, first of all, we will talk about the EP architecture, how it's set up today, and how we think, or I also brought an example, how we think it should look like in the future. Then we will talk about spare hardware resources. You can already imagine that you should need some space left when you think of new applications in the future. Then we will talk about the software in the car, but also in the backend, which you need to build up your system on. Then we will also talk about collaboration, the cloud-enabled software factory. It was already in the video. The way how we work together and how companies work together in one repository is changing everything. I think this is maybe the biggest change with this whole trend. And last but definitely not least, we will talk about services and skills. Okay, let's start with the architecture. As I mentioned before, we want to abstract the hardware from the software. We want to be able to deploy software innovations to the fleets. And we want to make use of COTS, components off the shelf. What I mean by that, I will explain in a minute. And we want to be able to have late hardware changes even during production. Right? And of course, we also want to achieve cost reduction. Okay. Now, this is a picture, like an example of how a future EE architecture could look like. We have to think about where do we come from. We come from a functional-based EE architecture where every ECU, every application had its own ECU, and this caused, of course, lots of weight, lots of hardware in the car. Lots of weight means lots of costs at the end, right? And with a zonal HPC-based EE architecture, we have a centralized EE architecture. And what you can see here in yellow are the high-performance computers that that are running on microprocessors and system on chips, and that host several functionalities and also highly complex functionalities like ADAS, so autonomous driving, and infotainment in vehicle. Surrounded are the high-performance computers by the so-called zonal controllers, and they are building kind of an abstraction layer to the sensors and actuators that are the edge nodes, how we call them, and that are surrounded. So the zonal controllers and the high-performance computers are connected with a service-based communication. And the sensors and actuators still have a signal-based connection to the zonal controllers. So they keep on sending signals to the zonals, and the zonals then decide or aggregate those signals. Okay, thank you. They aggregate these signals and send it then to the HPC. So all the complexity moves from the sensors and actuators towards the zonals and the high-performance computers. And this is exactly the decoupling of the hardware from the software. If you can imagine, you can now just exchange a red box or a blue box without having big changes in your software. And I think this is a big game changer. And we will also see it afterwards in our demo, what it means to just change the light indicator of a car. In the past, you would have changed also the hardware maybe. Must configure the gateway again. So there was a lot of effort, but now this is much easier. Okay. I quickly want to highlight what are the benefits of such an EE or centralized EE architecture. Very obvious, we have less wires, less boxes. That means less weight and less costs. But this is not all. The decoupling enables that we can bring in new functionalities even after the car was produced. So we can exchange sensors and actuators and have new functions in the car. And as you can also see in the picture, we have a connection to the backend. So the OTA updates are coming to the high-performance computers, and by that the hardware is not impacted. Okay. Let's move on to the second enabler that we have defined, the spare hardware resources. And this might be something for your purchasing departments, because engineers might be quite happy about this, because having more space left on in RAM and ROM makes the engineer's life much more easier, right? Some of the projects we see, so Niels was also involved in these kind of projects, have high CPU loads close to SOP, so they have to do timing analysis and see how to bring down the CPU load. So when thinking about maintaining a platform for several years, you have to think about some leftovers. In RAM, so from the performance-wise, also the memory, of course, then you also should think about leave some room for complex algorithms. If we think about ADAS, level 4, level 5, there should be some capacity left. Then you might want to have direct I/O access. So for quick response times, some functionalities require this direct I/O access. And if you don't have that, you cannot bring the feature. And last but not least, you need to be prepared for more communication and a higher bandwidth. But I think with gigabit Ethernet, we are quite good. Prepared for the future. All right. Now we're coming to the third enabler, and by that I will hand over to my colleague, Brandy.
Thank you, everybody. I do appreciate it. So I'm going to talk about 2 of the 5 enablers, and as Tobias already went through the first 2, which are crucial in terms of how you realize your software-defined vehicle. The next 2 are just as critical as you think about what this new vehicle architecture unlocks and enables in terms of the future of what this vehicle can do for the consumer in terms of personalizing and tailoring an experience for them that can live beyond SOP. It really goes after the vehicle, as Tobias highlighted, in terms of really giving that 10-year plus experience continuously, so allowing the value of the vehicle to continue to be enhanced and increase over its life. All right, so when you think about the software base layer, typically people call this the platform architecture, or they will say things like base layer or the critical integration layer, if you will. But the point here is a lot of times it's known as the middleware. So when you think about the technology stack and what it looks like when it gets built up, it goes hardware, OS, then you have the middleware, which is that integration piece, and that sits on top. What sits on top of that is the application, which unleashes the services and functionality that you can see, touch, and experience. The middleware isn't something you can see, touch, or experience, but if it's not there, you know it. And so when you think about the middleware and where it started in terms of being a background player to where it is today to being a more critical piece in terms of how we are able to realize the software-defined vehicle, you have to think about its purpose before and its purpose now. So the purpose before, it was traditionally serving as effectively the glue that would connect software elements inside of a vehicle, and now it's taking on that critical role of really being that central integration layer that allows the communication of these more complex software systems and the modern vehicle architecture that was highlighted earlier with the zonal approach that was shown as an example as you go forward. So when you think about all of what's happening with the middleware and the role that's playing, it becomes important and necessary to understand the role that Vector is now taking on in terms of being one of the, I'd say, uniquely positioned providers in the industry as we look to software and we look to this new software-defined approach to how these vehicles are enabled and put into the road. And so when I think about this, I think about all the factors that have contributed to this. A lot of the cues that we've gotten from our personal electronic devices, especially our phones, consumer electronic devices, they have, in effect, along with certain disruptors like Tesla, have now positioned and then you move over to the MicroStar Classic, which is typically on your zonals that facilitates that information exchange between the different communication protocols on the zonal architecture, as you can see on the graphic below, and then moving over to the more complex ECUs, which is your HPCs, and your HPCs is where the adaptive AutoZar sits on top, and this is where you get into that service-oriented architecture. And that service-oriented architecture is so crucial to the software-defined vehicle because when you think about your actuators and sensors, what it's doing is capturing that raw signal data that you get from your wheels and different types of sensor sets across the vehicle, pulling that information, that raw data up into what I would call data packets that become service subscription services that the applications that would sit on your HPCs would subscribe to. And as this picture depicts, you have your IVI, your ADAS, and different external ecosystems that tap into the architecture, the software systems, to get a hold of that raw data to unlock some of these services and functionalities that you can experience. And so from a Vector perspective, as you look across our software solutions, we have MicroStar RO, Classic, we have firmware for hardware security, we have switch software, firmware, and then adaptive AutoZar, and then we go into the cloud. So we go from in-vehicle to cloud, and for the cloud side, this is where you have your end-to-end over-the-air updates. And this is where it becomes that efficient update need, after production becomes critical. And so what we've done is enabled update software on the client side and also on the cloud side, so we can collect data not only from our software components but data across different systems within the vehicle itself. It all depends on what your needs are and what type of data you're trying to collect, but we have that ability within our software solutions to collect that and create a data lake so that you can pull that data and look at how you want to utilize it to enable different services and features for that consumer of that product. And so this is our base layer software, and we kind of covered the full scope. You don't necessarily need to buy all these pieces at once in order to have that synergistic effect, which is what Tobias was getting at. It's very open and modular, so you can buy it as needed and requested. And there's a lot of tier ones in the room that have purchased different pieces of software from us and used it to build up their ECU devices. And so what I'm going to do now is show you a demo. We don't have a live demo today, but we do have a video, and I'll walk you through what we would have shown you live on this video. So what you see here, just from a visual perspective, is Tobias highlighted a little bit earlier when he said that from a software-defined vehicle, you don't need to change the hardware to facilitate changes that you can see, touch, and experience. And so our use case here is this indicator light. This is the lights that can be changed to a different color. So what we're going to do is walk through the steps necessary to go from this orange color to a blue color indicator light. And so the first step here, or the first thing I want to make sure, just to ground everybody on what they're seeing, is this is a hardware board, which is a very close view, but what it is a scaled model of what an SDV architecture would look like. And so you have your endpoints, which are effectively your sensors and actuators that would contain your MicroStar IO software solution to pull in those raw signal data, and it get packaged and pulled into the zonals to communicate that to the application that would reside on top of this HPC that would house the adaptive AutoZar solution, which is a service-oriented solution that would then subscribe to those signals to be able to facilitate the change into the indicator lights. So here's the application itself, and like I said, we're gonna go from yellow to blue. So first you would change the code here. Once you've made the code, you commit that change into Git. Once that change is then committed, as you just saw here, it'll get synchronized, and then we can save the file and then move into our pipeline. So this is where that automation, that continuous integration, continuous test begins to get deployed. And so this is effectively our pipeline. And as you can see, as you look at this demonstrator of the different, let's call it, areas of how the product itself gets built, integrated as far as the application, and integration with the platform software, building the libraries, and then it gets tested across a different set of different test suites, and then that gets packaged and deployed into the fleet. So right now, we're doing step 2 of what the demonstrator would have shown you live. And so now at this point, I'll just go ahead, and this is just gonna run through the pipeline. And one other thing that I want to illuminate that's not visible is the tools behind it, and you'll see this in 1 or 2 slides, is the different tools that my colleague Marcella will go into in terms of the automated testing around seal, heal, and ultimately deployment into the vehicle. But this is so crucial in terms of acceleration and being able to automate all the manual work that you've been doing before as a developer at your desk. And now all of this is in one single environment. I'm going to a cloud-native approach to development next. All right, so now we're going to create the campaign into the cloud. And so with this particular interface, and as I said, Vector has end-to-end over-the-air update solution, but when you facilitate this campaign update, it's role-based, and you walk through this creating different, the best, but basically you have to configure the rollout, and you have to set up all the different parameters, and the video itself is not a little quicker than the actual me speaking and talking through it, but you configure the rollout parameters, and change the roles. The parameters consist of what software version are you going after, what fleet of vehicles that you're picking. So here we have the engineering fleet. And then we have to switch between different roles because you don't want the same person who created the application change to be the same person to approve the changes, because you want to have some level of discernment between the different roles, so that way you don't destroy or disrupt the fleet and how it works and functions. So now as we change roles, we look for what was created, approved, that gets approved, and then it gets rolled out into the fleet. So then we're going to start the rollout. And you can see here that will get deployed into the target itself. And you'll see the change here. So it's that yellow, but now it is now blue. So this was the demo you would have seen live, but now you get to see it on the video. And I'm happy to go into more detail about that. But how does all of this come together? In terms of the platform software, the application, and the actual deployment into either a target hardware set or into the vehicle itself. What we, our perspective, this next key enabler is the cloud-enabled software factory. It's so critical in terms of how the different teams across companies and across departments within a company work together and collaborate into a single space, utilizing the same tooling, the same types of software to facilitate the development of the platform and the application and get integrated into one binary that gets deployed into the vehicle. So let's just get into it. So as far as the cloud native software factory, this, as you just saw, facilitates high automation It enables a standard host environment across teams, so geographically dispersed teams are able to collaborate in one environment without having to set up their own individual, let's call it design environment with the tools and all the integration and configuration necessary to work with a set of platform software and the application that is built, and it's designed to facilitate parallel and decoupled development at once. And so I'm gonna just circle back real quick. As you can see in this corner here, a little graphic that shows as you do the visual, let's call it design environment with the tools and all the integration and configuration necessary to work with a set of platform software and the application that is built, and it's designed to facilitate parallel and decoupled development at once. And so I'm gonna just circle back real quick. As you can see in this corner here, a little graphic that shows as you do the build, integration, and test, what types of tooling is unlocked. And you can see during the integration, you have different vector tools unlocked, which is DaVinci Developer, Configurator, and DaVinci Teams, which helps automate a lot of the configuration, the provisioning of the platform software with the application. And then it gets built, you run some timing analysis, and then we also have VectorCast, which exercises the code, so really checking the code quality. And then you get into the actual testing, which Marcelo will go into a little bit more in depth around the virtual ECU and what that looks like as you go forward. And then you have a dashboard that tells you what's your error states, where the bugs are, where vulnerabilities are, things of that nature, and things that as a developer you have to go in and correct. And so the key here is bringing together geographically dispersed development teams into one single environment. And this helps with scaling. It helps with everybody utilizing the same environment to accelerate the time to market and be able to utilize the same artifacts, so that way you have a uniform approach to how you facilitate software development as far as putting together the right components to bring one unified tech stack into the ECU unit. All right, so from a software factory perspective, there's multiple roles, and as we've met with customers over the last couple of days, we've talked through what those different roles could be. And typically a project team will house architects, developers, integrators, testers, but they're all working in their own silo in a very manual fashion. And one of the things that we kept hearing about is automation, AI. Is there ways that we can all come together in a single space? And so this is what Software Factory is all about. It's not a product per se, but it's a concept. It's a way to bring these different roles together that would normally have their own journey of how they develop and test the software into an environment that will help automate that and bring these different roles in a unified way together to bring that binary to one piece of software that is deployed. And so I just want to highlight a couple of speed bumps here, if I can. There we go. So, like I said, a hindrance is a lot of manual processes, so we want to get to that automation and reuse. We want to be able to get fast feedback, and this is what the Software Factory does. It allows for that traceability and that quick feedback to allow for continuous improvement. And you avoid like having to wait for developer A for developer B to do anything because they're waiting on developer A. And then you have, different merge conflicts. One of the paradigms that we bring into the Software Factory from a vector perspective is this approach called everything as code, which I'll highlight in a little bit more detail in the next slide. but the everything at code approach really treats everything from requirements, design, configuration, integration, testing as code. And so that way it helps accelerate time to market, but it also unlocks and enables, okay, 5 minutes, okay. Let me go a little bit faster because I'm going too slow, but it helps unlock the ability. One of the major conflicts with the development process we do today is the fact that we have too many, one of the biggest pains is the merging of AR and XML files and resolving that because of the GUI setup. So now we're going to this text-based format, which is what everything as code is all about. It helps allow for that quick automation, collaboration, speed to market, continuous improvement be put in place. And then, of course, the scalability of the development team being onboarded into the software factory and producing consistency and reproducibility. All right. And Tobias will go into skill development a little bit more and how we are uniquely positioned to do that. So I try to get through these slides in 30 seconds, but effectively, the software hub, you got the software factory, it brings across multiple stakeholders. You'll utilize, of course, standard DevOps tooling like Git, like you saw in the demo, but then Vector also has unique positioning around different engineering services, so you can tap into our expertise, our 35-year history of working with development teams across tier ones in the supply base into a software factory context, because now this is becoming critical as you think about the software-defined vehicle, because the stakeholders necessary to bring this to realization touches everybody across the value chain. And so this becomes the central hub of how all these stakeholders come together and the pipelines that you need to facilitate to get it in place. All right. So when I talk about journeys, there's really two: architecture journey and the development journey, which a lot of times people look at architecture journey as the platform journey, so really identifying the network topology, the hardware selection, as well as the communication protocols necessary to put this into the vehicle architecture. The development journey is all about the application development. And so as you can see here from the picture depicted, that it's really different types of workflows, like I said, that can be done in parallel or in a decoupled fashion, and then it all comes together during the configuration and integration, and then ultimately to the deployment into the vehicle. All right, and this is what I was referring to in terms of everything as code. Literally all things are code, and it gives you that ability to be a little bit more proactive in terms of automation and resolving that whole merging conflict by going to a text-based solution and giving the need for less complexity as you move forward. All right, and I'm gonna skip over this slide because I kind of highlighted what Vector does, and ultimately, at the end of the day, it unlocks the ability to be agile and to have that fast feedback. All right, and so definitely I'm here for additional questions. We can talk a little bit more in depth about what software factory means. The key here is everybody has an individual way in how they work and develop software, so we are here to help you do the best in terms of gaining efficiency and optimization in terms of how you work today and how we can collaborate closer. All right, with that, I'm gonna turn it over to Tobias to talk about the last element, skill development.
Okay, real quick. Last but definitely not least, services and skill development. This is the reason why we are all here together today. And what we want to achieve is collaboration beyond company borders, right? I'm going to tell you something. We have seen ECU projects with more than 300 people, engineers involved from different vendors, different partners, and they all needed to be able to work together and speak the same language on a technical level. And that's why we call them the SDV hubs. This is also announced in the news that we have worked together with Mercedes-Benz, Stellantis on their specific vehicle OS. And there, this kind of collaboration is necessary. And of course, we don't forget about our key customers, the tier ones. We offer services to help them build up these software factories and base layers and participate in this kind of collaboration. And when I talk about skill development, in the end, with all this automation, maybe AI in the future, there are still people working on these ECU devices. And as I said, the complexity of these kind of projects is increasing. So more and more people need to be able to work together and seamlessly. And that's why, as Niels already mentioned in his presentation, we have Vector developed this kind of certification program to ensure the quality level of people's knowledge. And we're very proud to announce that Modular is our first partner in Latin America to help us to share this knowledge in the region and for individuals and also students. We will see, we have big plans, what we want to achieve here. We want to help building up this ecosystem. And yeah, those guys from Modular, they have undergone a long training, like a 6-month training. So it was, I think, quite stressful for them. But now they are certified by Vector and can help us to give this training to the people. And yeah, well, having said that, I hope we could give you some insights about what we mean with SDV, what is the trend about, and as Brandy said, we are here to answer all your questions. We are happy to have conversations with you and follow-ups, of course. And yeah, then I would end the speech. Thank you very much.